For this part of our factoring unit, we're going to be factoring by grouping. So your essential question is, when do I use the factoring by grouping method? So let's take a look at some examples. So let's look at factoring a 4-part polynomial. For example, if we have 8x cubed plus 4x squared plus 12x plus 6, and they want us to factor that. We're not used to having a 4-part polynomial that we have to factor. So what you have to do when you have a 4-part polynomial to factor is either take out the greatest common factor or factor by grouping, or sometimes you have to do even both of those. So the first step that you're always going to take is you're always going to check for a greatest common factor. So if we look at the example that we have, 8x cubed plus 4x squared plus 12x plus 6. What would be the greatest common factor of this polynomial? Well, if we look at all of these numbers can be divided by 2. Now, all of them do not have variables, so we cannot take out an x. So we would just take out a 2. So if we take out a 2 and we divide that out from each term, we would have left over 4x cubed plus 2x squared plus 6x plus 3. Okay, so now we've taken out the 2, but we still have a 4-part polynomial inside here that we need to factor more. So what we can do, since we have 4 parts, is we can factor by grouping. So the second step is to group what you have into binomials. So you're going to group them into 2-part sections. So I'm just going to take a different color so we can see, but I'm going to group these into 2 sections. And notice that I kept the plus sign with the 6x to show that that was a positive 6x. Okay, so now what I'm going to do, now that I've grouped them, is I'm going to factor each group. So to factor each group, what I have to do is take out the greatest common factor of each group. So I leave the 2 that I had in front, and then what would be the greatest common factor of this first group of 4x cubed plus 2x squared? Well, both of those numbers can be divided by 2, and if I look at the variables, the smallest number of x's that I could divide out would be x squared. So I'm going to take out a 2, and I'm also going to take out an x squared. So if I take out 2x squared, then what is left, 4x cubed divided by 2x squared. 4 divided by 2 is 2. X cubed divided by x squared. If I have 3 and I take away 2, then I have 1 left over. And then if I take 2x squared divided by 2x squared, I just have 1. Okay, then from the second group, if I look at the next group, 6x plus 3, what would be the greatest common factor of 6x plus 3? Well, both of those numbers can be divided by 2. So I can take out a positive 2, so I'm going to put a plus 2 because it's positive. And if I divide that out, 6x divided by 2 would be 3x. And, I'm sorry, that is not what I wanted to take out. 2 is not my greatest common factor. I'm getting ahead of myself. My greatest common factor would be 3. So I would take out the 3, and then I would have left over 2x plus 1. Now I have double set of parentheses here because I have this 2 that's in the very, very, very front from the beginning. So this part is in parentheses as well. So now if you look at what I have, ignoring the 2 that is in front, I'm going to see what my groups have in common. And I see that after I took out the greatest common factor of the first group, and after I take out the greatest common factor from the second group, both of these have 2x plus 1. So if I count this as one whole thing, and this as one whole thing, then what do these two things have in common? Well, they both have 2x plus 1. So that counts as a common factor. So what I would do from here, I'm going to leave that 2 from the very, very front. And then if I take out the greatest common factor from these, they both have 2x plus 1. And so if I divide that out from each one, then I have left over 2x squared plus 3. So this would be my final answer. These would be all of my factors. So if I multiply 2x plus 1 times 2x squared plus 3, and I double distribute that, and then I multiply that by 2, I will end up with what I started with. So this is kind of a trickier example. This is one of the harder examples that we'll do. So let's try some other examples. Alright, so we are going to factor by grouping. So if you go back and you look at your steps, the first step, always and every single time that you're factoring, is to check for a greatest common factor. So if I look at my terms, what would be my greatest common factor? Well, I have all of these numbers can be divided by 3. But this last one does not have a variable, so I cannot take out an x. But I can go ahead and take out a 3 from each one. So if I divide everything by 3, then I would get 9x cubed. And then 9 divided by 3 would be positive 3x squared. 9x divided by 3 would be positive 3x. And 3 divided by 3 would be positive 1. So this is what I would get after I take out the greatest common factor of 3. Then, because I have 4 parts, my second step is to factor by grouping. So I'm going to group these together into binomials. So I have this group here, and I have this group here. Okay, after I've grouped them, I need to take out the greatest common factor from each group. So I leave this in front. Then the greatest common factor of 9x cubed and 3x squared, I could divide both of those by 3. And I can also take out an x squared, because I can take that out from both terms. Then let's see what I have left over after I divide that out. So 9 divided by 3 would be 3. X cubed divided by x squared. If I have 3 and I take out 2, there would be 1 left. Then 3x squared divided by 3x squared would be 1. Then if I look at the second group, I have 3x plus 1. There is nothing that I can divide those by that they have in common besides 1. So I'm just going to pretend that I'm taking out a positive 1. And so I would still have 3x plus 1 left over. Because if I divide this by 1, it's still 3x, and if I divide this by 1, it's still 1. So now, if you look at what you have in common, this is 3x plus 1, and this is 3x plus 1. So if I think of this as one whole term, and this as one whole thing, they both have 3x plus 1 in common. So that is the greatest common factor I will take out now. So I leave the 3 from the very beginning. Then if I take out 3x plus 1 from both of these groups, that's one of my factors. And then I have left over 3x squared plus 1. So this would be my final answer. And again, you can check by double distributing. So 3x squared times, or 3x times 3x squared would be 9x cubed. 3x times 1 would be 3x. 1 times 3x squared would be 3x squared. And 1 times 1 would be 1. Then I have all of that multiplied by 3. So if I multiply this out, and I do it in order, 3 times 9 would be 27x cubed. Then I would take 3 times 3x, which would be 9x, but I'm going to say that because I want to write this in order. So 3 times 3x squared would be 9x squared. Then 3 times 3x would be 9x. And then 3 times 1 would be 3. So I get what I started with. So if you're ever not sure, just go ahead and multiply it out and you can check. All right. Last example. So first, it's a 4-part polynomial. We always check for a greatest common factor. There's no number that can be divided out because this one doesn't have a coefficient. And there's no variable that can be divided out because this one does not have a variable. So there's no greatest common factor. So then we just get into factoring by grouping. So I would group these into binomials. Then I take out the greatest common factor from each group. So the greatest common factor of this first group, can't take out a number, but I can take out a variable. So x to the third is the biggest thing that can be taken out. And then I have left over x squared plus 3. For the second group, notice that both of these are negative. Anytime you see a negative, you will probably pull out a negative number as your greatest common factor. So the greatest common factor of negative 4x squared and negative 12 would be negative 4. And so I'm going to put a negative 4 in front. And if I pull out a negative 4, then I would have positive x squared and then positive 3. So you'll see that that makes these two terms the same, which is what you want. So now that I'm looking at this group here and this group here, what do they both have in common? They both have x squared plus 3. So one of my factors is x squared plus 3 because that's the greatest common factor of these things. And if I take that out, then I have left over x cubed minus 4. And I could double distribute that and check, and I would end up with what I started with. So go ahead and make sure that you guys go back to your essential question and write your summary.